you. Thanks again, Hany, all yours.
Okay, thank you, and good morning. So yeah, so if you're not seeing me full screen, go ahead and put your Zoom in speaker mode, or go ahead and pin my video. I'm going to talk about some work that I did with Julia Dressel. She was an undergraduate at Dartmouth back in 2017. She graduated. And it is around the topic of predictive algorithms, particularly in the criminal justice system. Okay. I'm willing to bet that just about everybody on this call, if not everybody, has been subject to a prediction of the following form. If you liked X, well, then you may like Y. Amazon, Spotify, Netflix, Amazon Prime, music, movie, products routinely look at your viewing shopping habits, compares that to other people, and they try to make predictions. They're not that good, but they try to tell you what movie you would like. Sometimes they're right, sometimes they're wrong. It doesn't really matter, frankly, either way. Now, many of you have or will be subject to a predictive algorithm of the form. If you are like X, well, then we may accept you. So universities have started to use predictive algorithms as part of admissions. Companies, Amazon famously was using predictive algorithms to vet resumes to determine who would even get an interview. So more and more we are using AI predictive algorithms to make decisions about employment, university admissions. The stakes are a little bit higher, right? It's not about a movie recommendation or a product recommendation. It's about, do you get a job and do you get into a university? So here, getting it right and wrong, starts to matter, obviously, more. Many of you will at some point try to get a small business loan or mortgage, and the banks routinely use predictive algorithms of the form. If you are like X, well, then we may give you a loan. So they look at your credit history, your employment, your demographics, where you live, your banking information, and they make decisions. Are you at risk of defaulting or not? And then they make decisions on whether they should give you a loan or a mortgage. By the way, I noticed that a few folks joined late. If you cannot see me full screen, go ahead and put Zoom in speaker mode or pin my video, and that way you'll be able to see my slides, which if you're in the small icon mode, you won't be able to see them. More and more in this country, if you have a run-in with the criminal justice system, which I imagine nobody on this call has, you will be subjected to a predictive algorithm of the form. If you are like X, well, then we may put you in jail. So the courts around this country, and actually around the world, are starting to use predictive algorithms to assess risk. So if you were arrested and facing potential bond hearing or bail hearing that says you can be released with a cash bond or cash bail pending trial if certain conditions hold. And one of those conditions is now that a predictive algorithm assesses you as being low risk of recidivating, committing a crime in the future. Routinely, courts around the country at the local, state level are using this type of technology. Now the stakes are getting higher. We went from predictive algorithms on movie and music to what? Jobs, university admissions, mortgages and small business loans, to your civil liberties. So now when these algorithms get things wrong, we are now getting into some very, very dangerous territory. And we're going to talk about these algorithms and then about larger issues around these predictive algorithms as we get to the end of the talk. So if you haven't seen it, there is a terrific article by ProPublica called Machine Bias from, I think it must have been 2015 or 2016 or so. And they did an in-depth analysis of one particular recidivism prediction algorithm that is used today across the country in the courts. It's a commercial product that is used to assess a defendant's risk of recidivating, committing a crime in the future. And then judges can use that information to assess whether that person should be granted bail and given their civil liberties back as they wait to go to trial. ProPublica found some troubling aspects to this commercial software. It's called Compass. We're going to talk a little bit about that, and then we're going to talk about what Julia and I did to sort of think about this space. What they found is the following. So Compass, that commercial software, produces what's called the recidivism risk score, number between 1 and 10. 10 means you're at high risk of recidivating, 1 means you're at low risk of recidivating. Okay, so here's what they found. Looking at historical data, they found that the mistakes that the algorithm made were biased against Black people. Okay, so here's what they found. False positives, that is, you predict that somebody will recidivate, but they don't. That mistake happened 44%, let's call it 45% of the time if you were Black, but only 23% of the time if you are white. That's a huge whopping difference. So that is, Blacks were more likely to be said to be at high risk, even though they didn't recidivate in the future. And interestingly, and even more problematically, the other mistake was biased also against Black people. So the false negative, where you predict somebody not to recidivate, but they do, that mistake was made 47.7% of the time if you were white, but only 28% of the time if you were Black. So what does this mean from the predictive algorithm? That means if you're Black, you're almost twice as likely to be said that you will recidivate when you don't. And if you are white, you are twice as likely to be said that you will not recidivate, even though you do. And so the conclusion of the ProPublica piece was that this predictive algorithm used in the courts today, commercial product, is racist. It is biased against Black people. Okay. Lots of conversations emerged from this. Lots of academics chimed in on this. I'm not going to get into the whole thing, so it would take me an hour just to sort of talk about all the conversations that went around this. But so the story that I'm going to tell you goes something like this. So Julia Dressel was an undergrad at Dartmouth, where I was at the time. She read this ProPublica piece. She was taking a numerical methods class with me at the time, and she stormed into my office just completely outraged by this. Like, how is it that this predictive algorithm is biased against Black people and we're using this in the courts and it's taking people's civil liberties away? This is insane. You know, we should be able to do something about this. By the way, as a side note, I read the same article and I was outraged for like 30 seconds and went on with my day. But fortunately, Julia came into my office and started beating me up about not, you know, about thinking about this problem. And so we sat down and started talking about it. And there was a lot of discussions about, well, how do you define fairness, and are you using the right metrics? And, you know, and we didn't really want to get into that debate. And so we just sort of took a step back a little bit, and we started with a really simple question, because we couldn't find an answer to this, which is, presumably you are using these AI algorithms because there's an advantage to it. It's not about expediency. It's about, we want to remove subjectivity. We want these things to be more objective. We want to remove human implicit and explicit bias. And that seems like a good idea. Like, that's, of course, that's what you want in the courts. But it turned out we couldn't find anybody who had actually shown that the algorithms are any different than humans. Yeah. And so, you know, we just wanted a baseline. Like, so when we were thinking about, can we make these algorithms better? Can we make them more fair? What's the baseline? Well, the baseline is, well, we're humans. And if we can't do better than humans, well, I don't know what we're doing. And if we don't know what humans are, well, then we don't know if we're doing better. So we set out first to just understand, where is the human judgment in this task of predicting recidivism? Yeah, so let me talk a little bit about that. And then we'll come back to this whole bias issue with ProPublica and Compass and so on and so forth. Okay, so here's what we did. We had some historical data from the Broward County, which is the same data that ProPublica used in their analysis. So these are actual defendants. And we created a very simple mechanical Turk task, paid people $1 to respond to a survey. And the survey simply asked them to read a little paragraph. I'll describe this in a second. And then tell me whether they think the person being described here would recidivate or not. So in this paragraph, which is based on a real person, we told them a little bit of information. We said the defendant is male, so you get the sex of the person. We told them how old they were, 43. Notice, by the way, I'm not telling you the race, right? So you don't know if they're Hispanic, Black, white, anything else. All right, we'll come back to that in a little bit. Race neutral here. They are currently charged with disorderly intoxication. And then just to make sure some of these charges were a little bit unclear, we actually tell you what that charge means, so you can actually read what it means. This crime is classified as a misdemeanor. Two types of classifications, felony and misdemeanor. We explained to them in the precursor what that means. Most people know. And then we also tell you a little bit about this person's history. So this is their present, and the history is that they have been convicted of 2 prior crimes before. They have 0 juvenile felonies and 0 juvenile misdemeanors. Okay, so that's all the information. 1, 2, 3, 4, 5, 6, 7 pieces of information. And then we ask you, do you think that this person will commit another crime within 2 years? Okay. Yes, no, yes, no, yes, no, yes, no. 2 alternative false choice. And we give you a running accuracy as you go along, right? So we tell you whether you got it right or not on each trial. Okay? A little bit of feedback. Okay? All right, let's see what that looks like. So go ahead and try this at home. This defendant is female, age 29. They have been charged with aggravated assault with a deadly weapon. This crime is a felony. They have 0 prior crimes. They have 0 juvenile felony, 0 misdemeanors. Do you think this person will commit a crime in 2 years? Yes or no? Think about it a little bit. Pretty serious crime. They're pretty young. It's a woman if that matters to you, but no priors. What do you think? Yes? No? All right. In this case, the answer was no. This person did not, when they were tracked for 2 years, commit a crime. All right, let's do a couple more. Defendant is female, age 52. They've been charged with theft. The crime is a misdemeanor. They have been convicted of 6 prior crimes, 0 juvenile felonies, 2 juvenile misdemeanors. Do you think this person will commit a crime in the future? Okay, so it's a less serious crime, but they have priors before. Yes, no. In this case, the answer was yes. Okay, let's do one more. Male, age 22. They've been charged with possession of cannabis, 20 grams or less, small amount. It's a misdemeanor, 2 prior crimes, 0 juvenile misdemeanors and felonies. Do you think they'll commit a crime in the future or not? Yes or no? And in this case, the answer is no. Okay. And so this is it. This is the task, right? You read 50 of these, and we had thousands of them, thousands of defendants. We blocked them off. We got 20 responses per question there. And then I'm going to show you what the average accuracy is. Forget about the bias, just how well did they do in the yes/no task. So the Compass, which we have the data for because we use the same database that was in the ProPublica piece, was at 65.4%. So earlier on, I told you the bias of the algorithm, but I didn't tell you the accuracy. The accuracy is 65.4%. Not great, by the way. Our human participants were at 64%. They're essentially identical, right? And all they had are 7 pieces of information, and I paid them $1 online. Oh, and I told them that if they got 65% accuracy, that's why I gave them a running total, I'd give them a $5 bonus, right? On Mechanical Turk, that's a lot of money, by the way. And so we wanted to incentivize them to actually try to do the task. Yeah? And they basically got to 65% accuracy. Now, we pooled, I remember I told you each defendant was seen by 20 different people. And when we just did a very simple majority rules on that, we could get a little bump in accuracy, but only to 67%. And I report this because that 64% could be because you have a bunch of knuckleheads in there who just are really bad at the task, and then a bunch of people who are really, really good. But even when you integrate and do a little bit of majority rules, you're not really getting much of a signal. So the crowd accuracy, you ask a bunch of people and you do a majority vote, is a little bit better than the computational algorithm, but not statistically so. So basically humans with 7 pieces of data are just as good as the commercial software being used in terms of overall accuracy. All right, now let's look at bias. So we knew the race of the defendants, even though we didn't tell the participants the race of the defendants. So how did they do? False positives. Predict somebody will recidivate when they don't. Yeah. So without knowing the race of the person, mind you, our participants made that mistake 37% of the time if the defendant was black and only 27% of the time if they were white. Not as bad as the software, but still statistically significantly different. How? They don't know the race. That makes no sense at all. All right, we'll come back to that in a little bit. What about the false negatives? Same problem. If you're black, you only made the false negative 29% of the time, and if you're white, 40% of the time. So we have the same racial asymmetry and the same bias, and the same accuracy as the commercial software. This makes no sense at all, right? All right, so we didn't tell you the race and you were racially biased against the defendant. So we thought, all right, let's tell them the race and maybe people will somehow correct, right? They'll be like more careful. So we redid the entire experiment, hundreds of new participants, the whole thing all over again, exact same task, except this time we added in the race of the person. Yeah, so it's a white male, a black female, et cetera, et cetera. And we redid the whole study. Yeah, absolutely no difference. So without race, you were at 67% overall accuracy, crowd accuracy. With race, you're at 66.5, statistically insignificant, exact same accuracy. False positive, false negative. Without race, 37, 27. With race, 40, 26, almost exactly the same. False negative. Without race, 29, 40. With race, 30, 42, almost exactly the same. So whether I tell you the race or not, doesn't really make any difference in terms of accuracy and bias, which is weird, by the way. How is it that if I don't know the race, I'm still biased against Black people? That's sort of weird and interesting, and we're going to talk a little bit about that. All right, so we got to the end of this part of the experiment, and Julie and I sat down in my office and said, okay, where are we? Well, first of all, we've actually learned something, that these algorithms are actually, forget about the bias, right, which is problematic. First of all, they're not very good. And they're as good as a random person on the internet making this assessment. No criminal justice history. They're literally getting paid $1 to answer a question on an online survey with a potential for a $5 reward. And they're as good as commercial software. That is a pretty bad baseline, okay? So that's a little weird. And the question we have is, well, why? How is it that we only gave our participants 7 pieces of data? Compass has lots more data. They obviously have all the computational power that they want. So how is it that random internet users being paid $1 for a task are as good as this commercial software being used? That seems odd to us. And how is it that our participants and the predictive algorithm, Compass, what by the way will tell you is, well, we don't feed race into the algorithm, so we can't be biased. Well, that turns out not to be true, because when we didn't tell race to our participants, they were still biased against Black people. And so simply not telling somebody race, although I understand why you would think that, turns out not to be enough. But why? Okay, so we now have to answer these 2 questions, and that's what Julie and I set out to do, and that's what we're going to talk about now. All right, so here's what we're going to do. So what I'd like to do is get Compass, open up the box, figure out what the predictive algorithm is, and start sort of understanding, what they're doing to sort of get to those 2 questions about the bias and the sort of the similar accuracy to people on the internet. But of course, they have worked very, very hard to protect the underlying algorithm. We couldn't get access to it, right? All right, well, we're a bunch of computer scientists and engineers, so let's reverse engineer it. Yeah, let's do it ourselves. So here's what we're going to do. We don't know exactly, it was really hard to get exact information. So we just started with these 7 pieces of information that we gave to our participants: sex, age, crime that they were charged, the degree, felony or misdemeanor, prior crimes, and then prior juvenile. And we're going to feed that into our favorite predictive algorithm. I'll talk about this more in a little bit. And we're going to try to do a risk assessment in a supervised learning scenario where we have lots of historical data, and then we're going to try to make the prediction. So standard protocol, nothing surprising here. All right, so here's what we're going to use for this box. So let's imagine I'm going to, just so I can do the visualization a little bit easier, let's imagine I only have 2 things I'm going to try to make a prediction from: how old somebody is and the total number of juvenile felony convictions. Just arbitrary thing. Okay. So let's think about that in Cartesian space. I have age here, juvenile felonies here. I'm going to do the classic supervised learning. I get a bunch of data that I populate from people who did recidivate. I know their age. I know the number of juvenile felonies. I populate this space with a bunch of people who didn't recidivate. That's now the green dots. And what we're going to do is the simplest possible classifier. We're not going to use neural nets. We're not going to use support vector machines. We're literally going to use a logistic regression, right? A linear classifier. So we are going to learn a linear separating space. And we just wanted to start there because you should always start there. You should always start with the simplest possible classifier before you get the bazooka out that is the neural networks of today. Okay. And just by way of how we did this, it's actually pretty straightforward. Once you have this linear classifier, you can make predictions. Anything to up and to the left of that space is going to be classified as high risk. Anything down and to the right will be classified as low risk. Okay. And that's the basic idea. So we did 2 things. We did a logistic regression and a linear discriminant analysis. Let me just very briefly describe the linear discriminant analysis. It's extremely straightforward. You are looking for, in the 2D case, a 1D linear subspace. In the ND space, you're looking also for a 1D space because you're a 2-class classifier, such that when you project the data onto that linear subspace, you do 2 things. One is you minimize the within class variance. So as I project all these points onto this linear subspace, I compute the variance of all the red dots. I want that to be extremely small. And I compute the variance of all the projected green dots. I want that to be small. Why? Well, I want to do a classification. So I don't want the data spread all over the place. I want them to be very tightly coupled. Now, there's something else I want, because I can be very tightly coupled and be on top of myself. That's no good. So what the LDA does is says, please minimize the within class variance and maximize the across class variance. That is, I want the center of mass of these two classes to be as far apart as possible. And that makes sense from a classification perspective. I've now got things that are far apart and tightly coupled so the tails don't interact with each other. This is extremely easy to do. You can set it up as a generalized eigenvector problem. You can solve it in 5 lines of Python or MATLAB code. And I mentioned that because we're going to do a lot of these, and as you'll see in a minute. Okay, so that's what we did. We also did, by the way, did logistic regression. It's exactly the same as LDA. It's a slightly different objective function, but effectively you're learning the same linear subspace. All right, and then once we have that linear discriminant analysis, we can play with the threshold to balance the false positive and the true positive. So for example, if I draw the line here, very few false positives, very few green dots are on this side, but very low true positive too, because I'm missing a lot of things. And likewise, as I move the threshold, I get a high false positive and a high true positive, and we play with that threshold to get the balance that we want between the two of those to look as much like compass as possible. All right, so here's what we did. We had 7 of these possible data into this AI. By the way, I should say we didn't expect this to work. We just started off with LDA to be like, all right, let's figure out what the crappy linear classifier is. Again, we have baseline, and then we'll figure out if we have to get all the way up to a nonlinear classifier and neural net. We didn't expect it to work. So what we did is we fed all 7 of these into an LDA, and we got 65% accuracy, like same as before. We were like, oh, that's sort of weird. And we thought, okay, well, did we need all 7? What if we do all subsets of 6? What if we do all subsets of 5, 4, 3, 2? So just try every possible subset of just these 7 data, right? So the power set of all those. And the reason why we could do that, of course, is because we were doing an LDA. So each one of these took like 2 seconds to run, and we just tried everything possible, right? And here's what we learned. We learned that a linear classifier, whether logistic regression or linear discriminant analysis, with only 2 pieces of data, how old you are and the total number of prior crimes, not juvenile, nothing, just how many times have you been arrested before, gave me the same accuracy as the predictive algorithm that is being used commercially. That's the risk scale. This is my LDA at 66.8%. The same accuracy as the human participants. And it was no better than using any subset of size 3, 4, 5, 6, or 7. It didn't matter, right? This is all I needed. Now, if I only used 1 piece of data, I couldn't do very well. But with 2 pieces of data, I was basically there with a linear classifier, right? The accuracy is, so I don't know what Compass is doing, but effectively, it's a linear classifier on 2 pieces of data, how old you are and how many prior crimes. Now, what is it doing? Okay, so we have a classifier, and so we can sample that 2-dimensional space that I was showing you earlier, and for each value there, we have a probability of, what's your risk score. And here's what happens. On this axis is age, how old you are, and on this axis is the total number of prior crimes. And what I've done here is I've color-coded for every pair of age and prior crimes your risk. High risk is yellow up here in the corner, low risk is blue down here in the corner. And so what is this classifier doing? Well, let's see. If you are like me and you are in your 50s and you have committed, though, very, very few crimes, well, you're at low risk. Right? You went out, you did something stupid, but you managed to get to 50-year-old without getting in trouble before. Yeah, you're probably low risk. Yeah. On the other hand, if you're 14 years old here and you have 27 priors, yeah, something's going on. You're probably at high risk. Yeah. So what is it doing? It's looking at the rate of crimes that you are committing. And it's saying that, look, if you're old and you have a lot of prior, sure, you're still in trouble. But take a horizontal slice through here and notice that for the same number of prior crimes, your risk goes down as you get older. Why? Because I'm looking at the rate at which you are committing crimes. Right? That's it. That's all it's doing. That's all this linear classifier is doing. Yeah? All right, now let's go back to our 2 questions now that we've learned this. So, oh, I didn't show you, by the way, but our LDA is biased against Black people in the same way that our participants were and in the same way that the commercial software was. Exactly the same, almost the same ratios. How is that possible? I only know the age and the number of crimes. I think we can all agree that age is not a proxy for race, but number of prior crimes is, and here's why. In this country, if you are a person of color, you are significantly more likely to be arrested, charged, and convicted of a crime, balancing for all other things, the severity of the crime, prior convictions, everything. People of color are more likely to make their way through the criminal justice system than people who are white. Total number of prior crimes is a proxy for race. So when we were saying, well, we weren't telling our participants race, when Compass was telling us we don't know the race of the person, there was a little naivete there, because there are things that are proxies for race in our society. And because we have inequities in the criminal justice system, in particular, the way we arrest, charge, and convict, the number of prior crimes was simply a proxy for race, and it was slipping in. So if you are Black in this country, you are more likely, balancing for everything else, to have prior crimes. And because basically the linear classifier and presumably the participants were simply looking at, and this is the reason I gave you those examples from early on. So you remember that one person who had 6 prior crimes? What did you think to yourself? Yeah, they're probably high risk, as opposed to 0 prior crime. So we're sort of looking at the rate of offense. And that's where the race blindness is, the lack of race blindness is coming in. All right, we understand that. Now, why is the random internet user being paid $1 to answer a survey the same as a commercial software being marketed and used in the courts of law in this country? Why are those the same? Well, because the prediction is trivial. It's not doing anything complicated. Despite hiding behind a lot of good marketing and PR saying big data, big AI, inference, predict the future, it's basically a linear classifier on 2 pieces of data. I can write this software in about 10 minutes and sell it to anybody. In fact, I can write a web page in JavaScript in like 5 lines of code to take 2 data and tell you what the slope is of that. It's trivial. And that's why the human participants in the so-called AI are basically exactly the same. Now you could ask, well, okay, who cares? Commercial software, linear classifier, human participants, they're all the same. So who cares? Like, why is this a problem? Well, okay, so I would argue the problem is the following. Imagine you're a judge. Yeah? And let me just say something about judges, first of all. I do a lot of training of judges at the state and federal level. And very smart people, for the most part, know a lot about the law. But when it comes to technology, they are not particularly sophisticated. Yeah? So now imagine you're a judge with not a lot of technical sophistication. You are not computer science Ph.D. from Carnegie Mellon. Yeah, you're a lawyer. Yeah, due respect to lawyers. You have a commercial software and you are told, look, we have a commercial software that can predict the future. It's based on AI and big data and the latest advances in machine learning. And it has made a prediction about this person standing in front of you. And it says this person's at high risk. You would think that judge would sort of take that seriously. It seems authoritative. Yeah. Now imagine the same judge, same defendant, and the prosecutor says, somebody tweeted out that they think this person is high risk. Do you think the judge would care at all what some knucklehead on the internet said about the defendant being at high risk? Well, no. But here's the thing. Those 2 predictions are equally good. And so when you hide behind the big data, the big AI, and the seeming authoritative voice, I would argue it's dangerous. Yeah. The same is true, by the way, at Amazon. They were using a predictive algorithm to vet resumes to determine who got an interview. And guess what? It was biased against women. Right? So what it would do is if the resume had anything to do with the fact that you were a woman, women's volleyball, women's chess, women in science program, anything, your resume got downranked. Why? Well, because here in the Silicon Valley, women at the technical level constitute less than 20% of the workforce. And so the algorithm just learned that men are better than women because there's fewer women. And so we're simply trying to replicate the past. Well, first of all, that's incredibly idiotic because we've all known for years that we have a problem with gender and race in the Silicon Valley. And yet there is the stupid prediction algorithm simply repeating the same mistakes of the past. But it seemed authoritative, right? And it was great because they're getting these thousands of resumes and they vet them down. They're like, look, we got this AI algorithm. This must be the cream of the crop. And it was simply reproducing the same stupidity over and over again, but hiding now behind this. I would argue that that's incredibly dangerous. Okay, now you may be wondering, as we were, is, okay, we've got the commercial software, we've got the human participants, we've got our linear classifier, and we seem to be maxed out, 65% accuracy on the task. with a almost 2-to-1 bias against people of color. Can we actually do better? Lots of people have been talking about this. How do you assess fairness? What do you do? And so we were just sort of curious about this. And so we tried a couple of things. I'm going to just talk about one of them, which is, all right, let's move away from the linear classifier and go to a nonlinear classifier. Let's build a nonlinear support vector machine using your favorite kernel function. And we tried for months and months and months, trying everything under the sun using a nonlinear classifier to do better than the linear classifier, the commercial software, and the human participants. And we were simply unable to. Commercial software, overall accuracy 65%, human 64%, linear classifier 66.8%, nonlinear classifier, the best we could do was 65.2%. Right? We're just stuck. We seem to be stuck here no matter what we do. Yeah. Now, I would argue with absolutely no proof whatsoever that you're not going to do better than this. And here's why, is my argument. Think about the nature of the task I'm asking you to do. I'm asking you to predict the future 2 years down the road of a human being, of whether they will not just commit a crime, but actually be caught committing that crime. That's insane. That's an insane prediction to be making. So I would argue that given the level of uncertainty and the level of complex factors that must go into that result, I would argue this is probably about the best you're going to do. And 65% is bad. Put aside, by the way, the racial bias, that's bad, right? So here's the question I think we should be asking. I think we should move away in the recidivism space from how do you define fairness? Is this racially biased? Sure, we should think about those things, but I would make a more fundamental question, which is, should we even be doing this? Does it actually make sense? Now, on a more philosophical level, I take issue with using recidivism as the criteria for bail prediction. Bail is not about committing crimes in the future. Bail is about you are going to buy your freedom, and I just need to make sure you come back to court. That's what I'm assessing. So I think if the courts want to use this, by the way, separate issue, I take issue with bail because it basically means rich people can get out on jail and poor people can't. But putting that aside, because that seems to be for the most part law of the land. Maybe what we should be asking is not, can we predict whether you're committing a crime in the future, but can we predict if you'll jump bail? And that maybe we can do a little bit better. Maybe like, do you have family? Do you have a job? Do you have a history of jumping bail? How many? So maybe that we can get a little bit better. But even then, I would argue it's probably a tricky business. Yeah. By the way, as a side note to this whole story, here in California, we just voted on a proposition that proposed to eliminate cash bail. I'm actually supportive of that, but to replace it with a predictive algorithm. Yeah. That seems to be, the deal with the devil, right? You're getting rid of one bad thing and putting in another bad thing. So it got struck down, by the way, because I think a lot of people like me felt like these algorithms are not ready for prime time. Yeah. Okay. Last thing, if you go to my website, farid.berkeley.edu, you will find a science advances paper that Julia Dressel and I wrote now about 2 years ago that described, I didn't talk about all the nitty-gritty detail of the study and the algorithm. So that science advances paper has all of the details there. And Julia's undergraduate thesis has all of the details of everything that we did that didn't make it into the final manuscript. I will say, by the way, that Julia, who is really phenomenal young woman who did all the heavy lifting on this project, is now working at an NGO working on developing algorithms to be used in the criminal justice system with an eye to accuracy, fairness, and transparency. Okay, and I'll go ahead and stop there and take some questions if there are any. Thanks.
Thank you, Hany. People can unmute themselves to ask question.
Yeah, I don't think there's very many people here, so feel free to just chime in.
So did you try to predict if they jump bail or not, and how did that go?
We did not, and the reason we did not is we couldn't get the data. So I tried to work with this is when I was at Dartmouth, the state of Massachusetts, to get that data, and we were not able to get the data from them. Julia is currently working on that because she and her NGO now have very good relationship with a number of states around the country, and they are starting to get the data flowing in. My prediction is they'll do better. I don't think they're going to be at 99%, but I think they will do better is my prediction, but we don't know the answer to it yet.
And then what if you actually include race in your algorithm, because it should correct for it, right? It should actually, if race is a proxy for
prior crimes, a proxy for race, right? Yeah. So here's the thing. So if we put race into our linear discriminant analysis, nothing changes. It's exactly the same result. And now you could say, well, okay, let's correct for the bias. This is easy, right? So here's where things get interesting, is it depends on how you define bias. So we were looking at false positive and false negatives, which is what ProPublica was looking at as well. They were saying, look, the nature of the mistakes is that if you are Black, you're more likely to be predicted as high risk. If you're white, you're less likely, right? And that's a bias. What Compass came back with is, well, that's not the right measure of fairness. We look at what's called calibration, which is regardless of your race, are you predicted to be at high risk, independent of race? So depending on how you define fairness of your algorithm, you get very different results. And there's a beautiful article by I'm going to forget their name, some folks at Stanford, who basically show that there's these many definitions of fairness and bias in an algorithm, and you can't have them all be the same, right? You can't have a completely fair and unbiased algorithm using these different criteria. And the reason is that the underlying prior is that Black people, in fact, as a percentage, commit more crimes. And because we have that baseline that are different, well, it's actually not true. Sorry, I'm going to take that back. It's not that they commit more crimes. It's that they are arrested, charged, and convicted at a higher rate than when whites. Because of that asymmetry in the baseline, you can't have the algorithm be unbiased and fair across different measures. So I don't want to get into that argument. My view of it is, I don't know what the right measure is, but here's what I know. In the current system, if you're Black, you're twice as likely to be predicted as high rate. That has a real world impact on defendants, right? So you can play games with a different metric, a different objective function, but I don't really care. It doesn't seem that meaningful to me. But that's where the argument seems to be embroiled now, is how do we define fairness? I think the problems are more serious than that because the accuracy is so low. So I just say, like, I don't think you should be making the prediction. My view is just simpler than that, that's all.
Hany, I have a question, and this is something which I have not heard anyone talk about. It's about that bias in the data set itself, the underlying data that you are using to train a model. Nobody tries to balance that data set, and like, let's say if we have even race information, why not just make it like 50 and 50 and then say what is it that it's really doing? My guess is, when I look at these questions, I can't answer. I'm think yes, no is like these two hard boundaries. I can't really even say, will they commit a crime in 2 years or so years? I mean, there's so many things that changes, you can't really predict out of it.
That's right.
My hypothesis is that there is a bias in the data set itself, which, like, in both the training and the test splits, which has, let's say, maybe 60% is actually the 50%. And so if we remove that bias in the data set itself and we make this study, or say whatsoever Compass is doing.
Okay, so a couple of things. We are very data poor in this space. Most of us working on these predictive algorithms and recidivism are working on the same database. It's Broward County, Florida. It's extreme. First of all, it's Florida, which is already like, it's this completely crazy state. So already you're probably biased just because you're working with Florida data. It's a relatively small data set of, I think it's 8,000 defendants. So we worried about this a lot. And so here's what we did. Our analysis, what we did is we kept carving up the database into random subsets of size 1,000 out of 7,000. And we just couldn't escape the basic numbers, 65% accuracy, 2-to-1 racial asymmetry. So I think you're probably right. There's probably some problems in the data, but we couldn't sort of calibrate ourselves out of that no matter what we tried to do. And nobody else has either, as far as I know. Now, having said that, I'm not crazy about, essentially, years of research in this field being based on this one data set. So one of the nice things about what Julia is doing is she is starting to get a much, much richer much more geographically diverse data set. And we'll see if these numbers change. But, you know, I will say that the commercial software use this database as proof of concept. So it's not like ProPublica picked this database out of a hat. It is the data set that that the commercial software has used to validate their work. So I think it's a fair criticism to look at that same data set, but there obviously are limitations to it.
But so going back, I know that our intention in designing such an algorithm is to remove, say, human biases. But the problem in itself can't be just defined within a paragraph or within some dimensions. A lot of things that happens to someone in their life for 2 years or 4 years or 5 years. Is it even necessary to have such a system at first place?
Well, first of all, I think that's exactly the right question. And I would argue that if you are trying to predict the future 2 years down the line based on some basic demographics, I think you're out of your mind.
Yeah.
What you just said, I think people are complicated, and we don't even know. There's this idea somehow that your trajectory for the last whatever number of years is going to be able to predict what you're going to do in the next 2 years. I think that's insane.
Yeah.
It's completely insane, I think. So I'm skeptical of the whole venture. Yeah. I mean, putting aside that, you know, there are real problems with the software, the bias, the accuracy, all of those things, you know, let's say that you had an algorithm that was 99% accurate and completely unbiased. Yeah. First of all, do we think that that's achievable? Because I think that's where you need to be if you want to unleash these algorithms. And I just don't think you're going to get there. I just think it's a naive way to think about human nature.
Yeah.
One other question. What do the judges actually say? How was, I mean, these are cases where were actually decided by a person and they, right? So, without the software, right?
Yeah.
So how did they, how good are they? I mean,
a great question.
And it might still be that the software is only 65%, but the judges are only 55. I don't know.
Good. So this is a great question. So first of all, I think you're actually right that maybe the people on the internet who are completely naive and have no experience are actually less biased because they're just, you know, just doing their thing. Whereas a judge who may be a little arrogant, they don't even know where their biases are, maybe they're worse. So when I was talking with folks in Massachusetts, I tried to get the state Supreme Court justice to let me test his judges. Yeah, so I had very, very long and interesting conversations with the Chief Justice of the state Supreme Court in Massachusetts. He controls the judges for the whole state. He really wanted to let me do the study. Like he wanted to test. And I said, look, what if their judges are actually better? What if they're worse? I think we should what if they're the same? We should know. He's like, I agree. But he wouldn't let me do the study because he was worried that if in fact the judges were worse, it would look bad. I don't think that's, by the way, a good reason not to do it, but I understood his position and I could never get the permission to do it. I would love to test the judges. I'd like to test parole officers, prosecutors, lawyers. I mean, just people who are in the criminal justice system. Does having experience with defendants, does it make you better or worse? I have a prediction, by the way. I think it's going to make you worse. I think your biases of interacting with people is going to make you more biased without knowing it. But that's just a prediction. And I haven't been able to get anybody to let me test their judges. I think, sorry, I'm having trouble seeing your name because my screen is really small.
So I just had a question. So I mean, you talked about nonlinear models, but then you stopped at SVM. I'm not sure if you talked about neural networks at all, but that's one thing. And then the other thing is, did you think about probabilistic models? You know, I think human nature in itself is can be modeled in some sense with probabilistic models.
We didn't, so we stopped at nonlinear SVMs because we didn't get anywhere. That's not really a great answer, but the reason we didn't do neural nets is we just didn't have enough data. I mean, we only had like 7,000 data points and we just didn't think we'd be able to train anything even remotely large. And so we stopped. We did not look at probabilistic models, but other people have, and everybody basically gets stuck. It's all the same. That you never get past that 65% and the biases. Look, is it possible that if you had enough data and a deep neural net would learn something more sophisticated? Yeah, of course. I don't think it will, because usually you see the trends, right? You can see that from linear to nonlinear things, like usually you know what that trend is going to look like. So the fact that we couldn't get improvement no matter what we did, that's not a proof, obviously, but it makes me skeptical.
So I can make a pointer over here. Cynthia Rudin at Duke has been working on this data set for a long time now. So she gave a talk at AI Seminar last semester, and she showed that if you just use simple decision trees, they works much better than the neural networks. So you can look at her talk or her work that she has been doing.
That's exactly right. Yeah.
Thank you. Yeah.
Jose?
Yeah, so I have a quick question. So because I know, like, for example, lab from Yuri Leshkovich, right, that they did this with judges. And basically what they found was that in the case of judges, their bias is actually towards people that have families, right? Which you're not accounting to that in the, and yeah, so I mean, the other one is, I mean, that was just a note, but the question is that, because you're saying, this is not useful, but eventually this decision is, the no action means that they're going to all be put in jail, right? Theoretically.
Well, not necessarily. So for example, in New Jersey, they're just eliminating cash bail. There's like, look, if you get arrested and you're not, a clear, mass murderer, you killed 20 people, like you go home, right? And so, there's a lot of people out there advocating that if you are arrested and you have not been found guilty of a crime, except in the very rare case when you are a clear present danger to somebody, domestic violence, murders, you go home, right? So that is not an unreasonable position. Now, obviously, a lot of people who are on the public safety side will say, well, this is really dangerous. I think that experiment is going to play out in this country, right? Because some states have started to eliminate, I think New Jersey and maybe New York, I can't remember now, have just started to eliminate cash bail, particularly for like if you're charged with possession of marijuana is legal in most places, but small scale possession, what are we doing putting people in jail? That's insane. Yeah. So, all right, well, I guess we're gonna have to do the experiment to find out. But I don't think I wouldn't propose that, okay, without the predictive algorithm, send everybody to jail. That's a very bad idea, by the way. I would say the other way is for misdemeanors and minor crimes, let them go.
And the last point because, at the end of the day, right, in terms of the bias that you have, let's say in the priors, this is a class problem, right? You really are not, in the system, no one has computed, right? What is the probability that given that you have priors, right? And whether or not we can compute this, but the only way that I can see that you can actually fix the algorithms will be to compute class priors, given that you're Black and you're from this state, what is the probability that your priors will be?
But look, I mean, here's the problem. If you're using historical data to write predictive algorithms to predict the future, you are going to replicate the past, right?
I agree. What I'm saying is, but the only way to correct them will be to compute class priors, and computing these class priors is almost an open problem right now.
That's right, exactly.
So I agree with
that's exactly right. And by the way, the same problem exists in this whole space in predictive policing, right? Where Los Angeles, for example, famously used this, where they try to make predictions on where crime will be committed. Well, guess what? They end up policing Black neighborhoods more, and then they catch more crime, and then they predict that Black neighborhoods commit more crime. And so it's a feedback loop in predictive policing. So these things all have very, very deep fundamental problems, and it's exactly what you just said.
Thanks.
Yeah, thank you.
Okay, other questions? We have time for a few questions, maybe. Anyone? Christoph.
Yeah, I still, as a scientist, I'm much more hopeful about algorithms. I'm here at the Robotics Institute, and I said I want to replace people with robots because it's always the people are the problem. But isn't there a little bit? Can we get some more hopeful message out of that?
Well, look.
One is, for example, we actually are able to test things, right? Because beforehand we were always sort of talking in the abstract, and like this group says the police is biased against us, or it's but now we actually have data, and we can say, okay, I mean, it's very surprising to see that an algorithm has a racial bias, right? And you actually, discover that, right? So, and it lets us, talk more meaningful about these things.
Yeah.
Right. Because, I would have guessed maybe naively that if you don't have race in there, then there's impossible to be biased, right?
Sure, not so much. So here's the problem, Christoph. First of all, despite being a technologist, I'm actually less hopeful about technology. I'll come back to that in a minute, but here's the problem is that you can't separate technology from the humans, right? There is a for-profit company that is trying to make a buck selling this software, right? And so the humans are still sort of poisoning the well, if you will, right? The technology doesn't sort of live in this sort of this clean vacuum, right? Where we can just all be pure about it. It's embroiled in this bigger, messy space, in my opinion. But also, look at the internet today. Look at the amount of mis and disinformation, child trafficking, human trafficking, terrorism, hate, divisiveness, sale of illegal drugs, illegal weapons. Look at how technology has been weaponized against individuals, societies, and democracies. The work that I talked about here is a relatively small part of what I do. Most of what I do that you may have heard in the introduction is thinking about that weaponization of technology. I mean, look, we're living through it right now, where a significant number of people are buying into the QAnon conspiracy, the conspiracy that the election was stolen. And that's because technology is being weaponized without the right checks and balances. So I'm less of a techno-utopian. I think we actually need fairly careful thought as we deploy technology out in the world. Because I think when it's unleashed, we've seen a lot of harm over the last 10 years. And I don't think that we have a good scaffolding, either as individuals, as scientists, or as regulators, and certainly not at the corporate level, to really think about the complex web of issues. That's sort of my view of it. So I realize it's not very hopeful, by the way. You've sort of caught me at a weird time. But yeah, I don't, look, here's the one hopeful thing. I think almost everybody agrees that bias in the criminal justice system is very bad. Yeah, that judges, whether they know it or not, and we do want to remove that. I'm just not convinced that the current state of what we are trying to do actually does that.
Let me ask you a question a little bit different, okay? So there's been lots of great invention, like the combustion engine, right? And the combustion engine is used in tanks and has been very successfully used in the Second World War with millions of people dead, right? Now we have a new technology to revolution, and certainly I completely agree you can use it for good or for bad.
Yeah.
But here's the question, which I like to ask you. Are we now a little bit smarter in asking these kind of questions earlier? Like, or do we just wait till, really bad things happen and then we wake up?
Good.
Because I mean, you obviously are looking into it already, and I mean, these AI things are pretty new, right? Yeah. I mean, a lot of these things. So,
well, okay. So look, we all woke up 20 years later. The internet is now the internet that we know is 20 years old, and we all have a pretty bad hangover because it seems like we fell asleep and the shit hit the fan. So you would think we would have learned our lesson, right? Like maybe we should be a little more thoughtful. But for example, people who are developing technology to create deep fakes, whether they're images or video or audio, have unleashed these on the public, GitHub repositories. And guess what? People took them and started creating non-consensual pornography where they take one woman's likeness and they insert her into sexually explicit material. And we wake up one day and we're like, oh, there's an app now that will take an image of a woman and remove her clothing. Oh, couldn't have seen that coming. Of course you could have. We seem to keep making the same mistakes over and over and over again. And I do think it's not malicious. I don't think it's malicious. I really think it is the sort of this techno-utopianism, right? This idealism that technology is not bad, people are bad, right? But that's sort of, I think, a little bit of a naive view of the world. And I do think we continue to make the same mistakes. Now, having said that, I do think there is more awareness. I do think we're a little bit better off than we were 10 or 20 years ago. I think our regulators here and abroad are trying to be more careful. There's a lot of NGOs working in this space. There's a lot of academics who are thinking about this issue. But I do think that a lot of those efforts are being swamped by the corporate interests, by the fact that there's a lot of money to be made. And when there's a lot of money to be made, a lot of these ethical issues and moral issues and regulatory issues tend to sort of take a back seat. But I do think that the next few years are going to be very interesting for the technology sector, because as we speak, by the way, Zuckerberg and Dorsey have been dragged back to the Senate Judiciary for yet another hearing. I think regulation is coming. I think President-elect Biden and Harris have said that they are going to be looking hard at the regulatory landscape. I just hope it's not draconian. I hope it's not too late. I hope we can sort of think about this thing sensibly and with some humility and try to have modest regulation to rein in the worst abuses, but still allow an open and free exchange of ideas and more innovation. We'll see if that works.
All right. Okay, if there are any more questions, we can just take one last maybe. No, then we should thank the speaker.
All right. Thanks everybody for hanging on yet another Zoom call. I know that's not the easiest thing to do day after day after day, but I appreciate your time.
Well, it's technology. It's technology. You know, it's so now we don't have to interact.
Don't try to sell me that Zoom is a good thing. Right now, that doesn't feel like it.
You know, I'm an introvert, and sometimes I don't mind if I'm here in another suppressed minority, right? Well,
I understand.
I'm not really, but some people forget they're introverts, which actually enjoy not having to meet so many people.
Yeah, I understand. Look, there's no, all good, all bad. Everything is complicated, right? This is the one thing you know as you get older. Everything is complicated.
Yep, absolutely.
All right. Thanks, everybody.
Nice talking to you. Yep.
Stay safe.